Hi everybody. Today let me see an example. This example show me how to on the derivative this kind of form. Okay. How to do this kind of question. Okay. Or here we create a constant like this, right? In order to the on the derivative formula, we have to change this function first. Okay. Now we separate this. On the derivative this function just same as on the derivative this function, right? This a b is constant. But how to determine okay. Let me see what is a and b. Now combine this one. Add it to 13 equal to 13. Okay. Now let me see how to do this one. X minus a common denominator. Here's a x minus 5 plus b x minus 1. Let me see here, channel 12. Let's make this a little bit simple. Okay, here. Now, we calculate the numerator and collect a common factor as ax minus 5a plus bx minus b. Here, copy denominator. X, that means a plus b x plus negative 5a minus b. Right. Now, last one, look at this, it's channel 12. This equal to this. Denominator same, numerator must be same. Then we got a plus b x plus negative 5a next b. That should be 12. Okay. Now, this constant is constant. Here's x. It's same, just like 0x plus 12. The coefficient of x right side is 0. That means a plus b must be 0. Right, constant 12 is constant. So negative 5a minus b should be 12. We saw that as x equal to negative 5b and x equal to negative b. Substitute down here. Negative 5 negative b minus b is 12. So what is positive 5? That means 4b negative 4b, no, positive 4b is equal to 12. Then b is 3. and we thought A is negative B, right? So A is negative 3. So now come back to this underderivative. It should be turned to this form. Right, that's equal to this one. Right. So A plus x minus 5 will be underderivative. So that should be A right now as negative 3. Right. Plus x minus 5. B is 3. Now we know this underderivative this plus underderivative this. This we can apply for logarithm. We apply the formula. That should be negative 3 log x minus 1 plus 3 log x minus 5. Now, write this as simple as possible. Apply for the property of the logarithm. That should be 3 factor out. Should be log x minus 5 x minus 1 absolute value. So plus c. Right here you're gonna plus c constant. So that is this question's answer. Okay. So next question. Let me see this kind of question. Series. Determine which series convergent or divergent. Let's copy this question. Let's be write as a second question. Question is which of the following series cannot be shown to convergent using limit comparison test rule? Okay, let's write on this one. Which of the following series cannot be shown to convergent convergence. No, let's miss it. Yeah. Convergent, right? By this method, using the limit comparison. comparison test with this series, the very important series. Start from one. First one. No. This one. First. Actually, it's multiple choice. Give you full answer. You choose which one is comparison. Use this method, comparison method. Use this series to compare. First, not clear. N is 1. Infinity 3n squared minus n 4. Second, psi n squared 1. Yeah. Third. Denominator is, let's see. Let's say that. Okay, square root. What is this? Oh, okay. Square root n squared minus 5. 15. Fourth. N squared log n 5. Okay, it's 5. Summation cotangent 1 over n. After 5 choice, they show me which one is convergent. How to determine conversion by use the comparison method, this method to show you with conversion. Before doing this question, I have to know what is limited comparison test. This rule. Okay. Here, mention a little bit about that. Okay, this rule show me if yes, okay. If A the limited okay. Remember, A the series A and Bn is a positive series, positive term, right? Okay. If this limit is C, the ratio two series, right? Two series comparison, An and Bn. If C is positive, then we can make a conclusion. Okay. Either both An and there's Bn convergent, or both divergent. That means two series we compare each term a n and b n make the limited. If the limited is positive, then this both series either convergent or divergent. That means what means? That means if this convergent, this convergent. Is this divergent, this divergent. This limited series. Okay. Or we can say we normally apply for this one, right? If the ratio of this is 0, and numerator this Bn and Bn is convergent. If Bn is convergent, then An must convergent. Okay. If sometimes maybe you ask this question, if this is infinity. Okay, now if the limit is infinity, how to determine the convergent divergent? Now this limit comparison test rule told me if Bn, if the infinity ratio of the ratio of this the limit is infinity, if denominator Bn is divergent, then An is divergent. So we normally just use this. That's okay, right? We should use this rule. Compare this one. Right. Now we test one by one. Okay. Solution. Let this be An, this Bn, 2 series. Right. Now we test this one. The key point is try to find the limited. Right. Now if the limited is positive, like this, compare this one, this very famous the series. We know this convergent, right? This is convergent. Both is if this limited is positive number, so both this either convergent or divergent. We know this convergent, so this one must be convergent. Like, okay, we have to find this limited. Right. Now what the limit? Very easy, right? Okay, so okay, here, yeah. Right, so this is easy, the limit of, yeah. Let me get as 1, 3 over 4 over 3, which is positive. So by the comparison, the limit comparison test, right? The limit is positive, so this both convergent or divergent. Now right now we know this convergent, so this must be convergent. So this one must be convergent, right? Or the question is cannot be showing. Cannot be. This one is convergent. Cannot be. This can show it. No, this. So this not the answer, right? Convergent. Second. It's very important. The limit, same as right? It's like it's 1. You know this one, right? X approach 0, x sine x is equal to 0. No, it's 1. X approach here 0, 0. And approach infinity, here 0. Here 0 is 0, right? That's 1. It's also positive. So they both convergent. So this one is convergent also. We can show this one is convergent. Convergent. The question is cannot be showing. This question we can show this convergent by this. The question is cannot be, right? Which one cannot be showing? Use this rule cannot be showing this convergent. So this is not the answer. Third. Same. Comparison just means n squared minus 5, 15. Here, yeah. This means I think the question copy is wrong. Oh, no wonder it's 4. So we know this limited. We take out this one, factor out this n fourth, fourth pulse is n squared, cancelled out. Right? This is 15. Yes. Limit is 15. It's positive. It's convergent. We use this rule. That means this one we can use this showing, right? This comparison rule. Use this one as comparison. No, it's also not. Now, which one cannot be shown? Convergent. False. Alright, here's the limit. N squared log n squared is 1. Alright. Make sure the question is right or not yet. So here's log n. So what it is? Infinity. So that's why is we cannot use this one's divergent. The C is positive, it's divergent. So number 4 is correct answer. Now last one, I'd like to try this one. Maybe this is also answer. Maybe this cotangent. Cotangent, and let's see if copy is right. Number 4 n squared, yes sir. Yeah. This one I can write cosine sine or n times n square 1 n square, we can write n square and okay, it's 1 over n. Oh, we can write like this. Very easy to tangent is to cosine or sine. This we can write like we can write like this. And n is like n o cosine n over. We know this one is 1. Limit is 1. And into infinity. This we cannot determine this one, right? This 1 over n. Let's see the question wrong not. Cotangent 1 over n is divergent. Okay, here's infinity. 1 over n over 1. Okay, here's question. I'm missing something. Oh, it's n squared. Sorry. N squared. Yeah, n squared. Sorry. Cosine n squared plus n squared. Here's n squared. Sorry about that. It's 1. It's 1. As n to infinity is 1. It's 1. N approaching infinity is cosine 0 is 1. S1 is approaching 0 is important formula. Same thing is 1. It's 1 positive. That's convergent. Thus in this question we can use this rule, limit comparison test rule. Test is convergent. Now which one cannot be showing to the convergent by this rule? Question is this. Number 4. Okay. Later I will show more questions about the series. Okay. Thank you.